Good morning, students. Now we'll try to find the differentiation of implicit function and differentiation of inverse trigonometric functions. Let us try them in exercise so that it becomes easier for us to understand. Let us see. Now we have this exercise for the differentiation now. Okay. So now we have, first thing we have from the exercise, we have the first question. That exercise is 5.3. Now we have 2x plus 3y is equal to sin x. Okay, so now we have this. Let's try to differentiate it. First we need to separate it out. Sin x minus 2x, y is equal to sin x minus 2x upon 3. So we have. Now we'll try to differentiate it as dy upon dx. We have 1 upon 3. Differentiation of sin x will be cos x. And differentiation of minus 2x will be 2. So finally I got my dy by dx. That is how find the differentiation of implicit function. Now let us try to do the second one. Now second question we have, that is 2x plus 3y is. Now the second question is, we have, what is the second question? That is 2x plus 3y is equal to sin y. 2x plus 3y is equal to sin y. So if I differentiate it, I got 2 plus 3 dy upon dx is equal to cos y. Okay, is equal to cos y. So what we have here, we can know cos y dy upon dx. What will happen? Take this at that side. So we got cos y minus 3. We have dy upon dx. So I have 2 upon cos y minus 3 is equal to dy upon dx. Okay, so that is how we try to find the differentiation of implicit function. Let us move to the third question I have, that is ax plus by square is equal to cos y. If I differentiate here, I got a plus 2by dy upon dx is equal to minus sin y dy upon dx. Okay, so now take that side. So I got, what I got here, the a is equal to minus sin y minus 2by upon dy upon dx. So I got a upon minus sin y minus 2by is equal to dy upon dx. Or what else we can write here? In a simple way, therefore dy upon dx, it will be minus a upon sin y plus 2by. Okay, so what we got, that is the differentiation of dy upon dx, dy upon dx is equal to minus a upon sin y plus 2by. Okay, now let's try to solve the fourth one. That is, we need to find the differentiation of implicit function. We have the fourth, xy plus y square. We have xy plus y square is equal to, xy plus y square is equal to 10x plus y. Okay, we have 10x plus 1. Let's try to differentiate. We have xy dy upon dx plus 2y dy upon dx is equal to sec square x plus dy upon dx. Okay, so now what we can do here, take this side so that we can take common. So we have dy upon dx xy plus 2y minus 1 is equal to sec square x. Okay, so now we have, that is therefore dy upon dx is equal to sec square x upon xy plus 2y minus 1. Okay, so that is why we find the, no, we try to find we try to differentiate the implicit function. Okay, so we have done 4. Let us try to solve fifth one. So what is the fifth one we have? X square plus xy, x square plus xy plus y square is equal to 100. Square plus xy plus y square is equal to 100. Let's differentiate it. We got 2x plus x. Here we will apply the product rule. That is x into differentiation of y plus y into differentiation of x plus y square is equal to 100. So now what we will do here, we will take all that side, sorry, it will be 0. Differentiation of constant term will be 0. So now we have this. So we will have x dy upon dx is equal to minus y square minus y. Wait, we have done x square plus y. How we can leave this as, because we have x divided x plus y into the differentiation of x plus, here we have 2y dy upon dx is equal to 0. Okay, so take other side apart from dy upon dx. So we'll find x minus 2y into dy upon dx is equal to minus 2x minus y. Okay, so now therefore dy upon dx is equal to minus 2x minus y upon x minus 2y. Okay, so that is how we try to, find the able to differentiate an implicit function. Okay, so that is what they have given. Now we'll try to solve the next question. We have just solved only 5. Now we'll try to solve sixth one. So now what the sixth says, let us see. Sixth question, we have done 5. So a lot more we need to do. Let's go for it. Let's sixth we have x cube plus x square y. The question, that is x cube plus x square y plus xy square plus y cube is equal to 81. Okay, they have given this. Okay, so now we'll try to differentiate it. Let's see. 3x square plus x square dy upon dx plus y plus 2xy plus, same here we'll apply the product rule, that is x into 2x into y dy upon dx plus y square plus 3y square dy upon dx is equal to 0. Okay, dy upon dx. Now what we can do here, take dy by dx that side. So I got 3x square plus 2xy plus y square is equal to, we have dy upon dx, we have minus 3y square minus 2xy minus x square. Okay, so now what we'll do, take this as that side. So we'll have 3x square plus 2xy plus y square upon, we have minus x square minus 2xy plus 3y square is equal to dy upon dx. Okay, so that is what we have here, that is minus. So that is how, if I take minus sign common here, so I got 3x square plus 2xy plus y square upon x square plus 2xy plus 3y square is equal to dy upon dx. Okay, so that's how we try to differentiate the implicit function. Okay, now we'll have next question, that is question number 7th. What they have given? sin square y plus cos xy is equal to pi. They have sin square y plus, that is what we have, y plus cos xy, cos xy is equal to pi. If I differentiate it, 2 sin y cos y dy upon dx is equal to, we have cos xy, so we'll have differentiation minus sin xy, and differentiation of that will be x into dy upon dx plus y is equal to 0. Okay, so what will happen? We'll take that side, so we'll have 2 sin y cos y. We have, that is sin square y plus we have cos xy is equal to k. So we have at 0. So we'll take that side, minus, it will be plus sin xy. We have x dy upon dx plus y. Complete, I have shifted to it to the RHS. Now what will happen? It will be sin 2y and upon sin xy, and we have, then we have left with x dy upon dx plus y. So now what we can do is take that side. Okay, so we'll have sin 2y upon I have sin xy minus y, we have upon 1 upon x is equal to dy upon dx. Okay, so that is how we try to differentiate an implicit function. Let's move on to the 8th one. They have given sin square y plus cos square y is equal to 1. They have sin square y plus cos square y is equal to 1. If I differentiate it, I got 2 sin y cos y dy upon dx plus 2 cos y minus sin y, because differentiation cos y will be minus sin y, dy upon dx is equal to 0. That's minus, we'll take on that side. So we have sin 2y dy upon dx. Wait, then we have sin square x, we have here. So we have sin square x. So here will be x. Okay, so we have sin 2x is equal to sin 2y dy upon dx. So now we both have dy upon dx. What will happen then? Divide them. Okay, so I got here, that is sin 2x upon sin 2y is equal to dy upon dx. Okay, that is how we try to find. We have here, okay, so 2 sin x cos x plus this, so we'll have taken this on that side. So we have sin 2x upon sin 2y is equal to dy upon dx. So that's why we try to differentiate an implicit function. Now what will happen? We'll try to differentiate inverse trigonometric functions. How? We'll try now. Okay, so we have, now let us try to differentiate inverse trigonometric functions. Okay, let's try. That is, now I am on 9th question now. Okay, so we'll try what we have here. Let us see. We have solved 8. Now let us see what we have in 9th question. So we have the 9th question here. That is y is equal to, 9th we have y is equal to sin inverse 2x upon 1 plus x square. Now what we can do here, put x is equal to tan theta. So we'll got here sine inverse 2 tan theta upon 1 plus tan square theta. So we'll have that is tan to theta. Okay, tan to theta, or as in that form I can write sine to theta. Else instead of writing exactly I can write it will sine to theta. It will be 2 theta now. Okay, so now what is theta? We'll have 2 tan inverse x. That is why. Now differentiate it. So you got 2 upon x square. Okay, so that is how we try to differentiate inverse trigonometric functions. Okay, so now let us try. Let us move on to the 10th question ahead. What they have given: y is equal to tan inverse 3x minus x cube upon 1 minus 3x square. But here they have given condition also, that is minus 1 upon root 3. Okay, x lie between minus 1 upon root 3 to 1 upon root 3. Now we have put x is equal to tan theta. So we have tan inverse 3 tan theta minus tan cube theta upon 1 minus 3 tan square theta. Okay, so we all know this formula, that is tan theta. Okay, so we have 3 theta, so therefore y is equal to 3 tan inverse x, or dy upon dx will be 3 upon 1 plus x square. Okay, so that's how we try to differentiate inverse trigonometric function. Let's try another one. We have 11th question now. So what the 11th question says: y is equal to cos inverse 1 minus x square upon 1 plus x square. 1 minus x square upon 1 plus x square. Okay, so now what we can do here, put x is equal to tan theta. Okay, they have to given the condition also. Okay, x lies between 0 to 1. So now put tan theta. So I got cos inverse 1 minus tan square theta upon 1 plus tan square theta. Okay, so now we have cos inverse, that is, now we'll have this, that is cos 2 theta. So we have 2 theta, so we can write 2 tan inverse x. Now why is this? So dy by dx will be 2 upon 1 plus x square. So we have solved 11 numericals. Let us try to solve 12th. Now we have, let us see what they have given in the 12th question. Okay, they have given, that is, in 12th, y is equal to sine inverse. Where is my question now? Let's try to see. Y is equal to sine inverse 1 minus x square. Okay, 1 minus x square upon 1 plus x square. We have this. So now y is equal to, we have sine inverse 1 minus x square upon 1 plus x square, where the value is, okay, where x lies between 0 to 1. Okay, 0 to 1. So what we'll do? We'll try to first put x is equal to tan theta. So we have sine inverse 1 minus tan square theta upon 1 plus tan square theta. So we have sine inverse, we have, so here that is the means will be cos 2 theta. Okay, so what we can write here, sine inverse sine pi by 2 minus 2 theta. Okay, so we have pi by 2 minus 2 theta. Y is equal to pi by 2 minus, we have 2 into, what we have, theta. Theta are tan inverse x. So if I try to do is differentiate it with respect to x, we got minus 2 upon 1 plus x square. Okay, so we have solved 12th question. Now try to solve 13th question now. So we have 13th question now. Let us see what they have given. In 13th, they have given y is equal to, we have cos inverse 2x, cos inverse 2x upon 1 plus x square, where x lies between minus 1 to 1. Okay, so we can say put x is equal to tan theta. So we have y is equal to cos inverse 2 tan theta upon 1 plus tan square theta. Here it will be sine 2 theta. We have the formula for sine 2 theta. So we'll write as cos inverse cos pi by 2 minus 2 theta. So we have pi by 2 minus 2 theta y. So we have y is equal to pi upon 2 minus 2 tan inverse x. So we have dy upon dx is equal to minus 2 upon 1 plus x square. Okay, so now let's try to solve 14th question we have. So what the 14th question says, let us see. 14th question is y is equal to sine inverse 2x 1 minus x square we have, and here they says that x lies between minus 1 upon root 2 to 1 upon root 2. So this is my 14th question. What we can do here, put x is equal to sine theta. So we have sine inverse 2 sine theta 1 minus sine square theta. We know that 1 minus sine square theta will be cos square theta. It will be cos theta because it is in under root given. So we will write sine inverse. That's my 14th question now. Sine inverse 2 sine theta cos theta. So we have sine inverse sine 2 theta. Okay. So now we have 2 theta. So y is equal to, we have 2 sine inverse x. So therefore, if I differentiate it, I got dy by dx is equal to 2 upon 1 minus x squared. Okay, so that is how we try to differentiate the differentiation of inverse trigonometric function. Let's go for one more question we have. So what we have, 15th. So now we have the 15th question. What they have given, let us try to find. Let us see what question they have. That is y is equal to sec inverse. Okay, y is equal to sec inverse 1 upon 2x square minus 1, where x lies between 0 to 1 upon root 2. So what we can do here, let us see. Put x is equal to cos theta. X is equal to cos theta. So what will have here? Sec inverse 1 upon 2 cos square theta minus 1. So we'll have sec inverse 1 upon cos 2 theta. So we'll have sec inverse sec 2 theta. So now we'll have 2 theta. Y is equal to 2 into, what is theta will be? Cos inverse x. So if I try to differentiate, we'll get 2 upon 1 minus x square under root minus. Okay, so that is how we try to differentiate the inverse trigonometric functions.